Okay, here's some more examples from 5.5. Let's look at the integral x cosine x squared. Now what you're going to notice is that these two terms differ by 1 degree. One's x squared, one's x, and that's what you're looking for. Terms that differ by 1 degree, because when you take the derivative, the power rule says you subtract 1 from the exponent. So you always pick u to be the highest degree. Now you wouldn't pick u to be cosine because the derivative of cosine is sine, so you have to think ahead by taking the derivative. So here we have u equal x squared, du equal 2x dx. And notice what we have so far. X squared is u, and x dx is what we need in this problem. So we get rid of the 2 by dividing both sides by 2. Okay, so the idea is pick a term with a higher degree, so when you take the derivative is going to go down by 1 degree. So let's replace everything. The x dx gets replaced by 1/2 du, and then we have cosine u. The integral of cosine is sine, and then we have a plus c, and then we replace u, so it's 1/2 sine x squared plus c. Let's try another one. Integral x squared over the square root of 3 minus 3x cubed. Now, anytime you have a square root, you should change it to the 1/2 power. And like in the other problem, don't you notice that there's a term that's 1 degree higher than the other? Well, usually we take u to be the terms inside the power. Remember, before we took u to be the terms inside the cosine. So that would be a good rule to follow. Now that doesn't always work, but 90% of the time that's what you do. Take the terms inside the power or inside the function, like cosine, sine, so on. So u is 3 minus 3x cubed. Immediately take the derivative and look at what we have and look at what we need. We said this was u to the 1/2, and x squared dx is what we need. We'll go back here, and you see we have x squared dx. So take the minus 9 to the other side. We get what we want. So in this problem, the x squared dx, come back and look, is minus 1/9 du, and we have u to the 1/2 in the denominator. And now we've changed the problem into the power rule. That's our whole point, to change this problem into u to the nth, or cosine u or sine u, but we want u to the nth because that's really the only rule we know is the power rule, which means we add 1 to the exponent and divide by the exponent. So this is minus 2 over 27, u to the 3/2 plus c. Now replace u with the x it was, and u was 3 minus 3x cubed. So choose u, take the derivative, and see what you have and what you need. Try another one. 2 cosine x over 9 plus sine x cubed. Okay, let's look and take the terms inside the power. So if u is 9 plus sine x, the derivative of sine is cosine. And wow, that's what we need. Cosine dx is what we needed. So that is du. We don't have to adjust it by the constant, and this is u. So our problem changes to 2 du over u cubed, which is easy to integrate. U to the nth again. Our whole point is to get this to be u to the nth, because then we add 1 to the power and divide by the same power. So we have minus 1 over u squared, which is minus 1 over 9 plus sine x squared plus c. Let's get some more paper. Let's try another one. 3x 2x squared plus 1 to the 1/3. Okay, by now you should know what to pick u. The terms inside the power, right. So if u is 2x squared plus 1, immediately take the derivative. And notice that these are 1 degree apart. X and x squared are 1 degree apart, and our x dx is right there, x dx. So get rid of the 4. Okay, you really can't divide by x or anything like that. You just want to get rid of constants. That's the only thing you're allowed to do here. So if you have to divide by an x or a term with x, then you're probably not doing it right. So we have 3. The x dx gets replaced by 1/4 du. And then u is 2x squared plus 1. U is what was inside the power. Again, u to the nth. So our whole point is to get this to be u to the nth, because to integrate we just add 1. Invert, multiply, and then substitute back. Okay, let's try integral square root tan to the 7th x secant squared x dx. Well, here you have to know that the derivative of what is secant squared dx. Remember, we always let u be inside the power. Now, we're not going to pick tan to the 7th, because the derivative is, using the chain rule, 7 tan to the 6th times secant squared, and that's not going to work. So if you let u be tan to the 7th, du is 7 tan to the 6th times secant squared x, and that is not in our problem. So, we will pick u to be inside the power, but we want the derivative to be secant squared, so that tells us actually what u is. If u is tangent x, then du is just the secant squared x dx. And actually that's true, because if you rewrite this as tan to the 7th x to the 1/2, we really have tan x to the 7/2, so it's natural to pick u just to be the tan x if you rewrite the problem. So here we have u to the 7/2, and our secant squared x, all of this is du. U to the nth again. Our whole point is to get it in the form u to the nth. So we add 1 using the power rule and divide by the exponent. Replacing it, we have 2/9 tan x to the 9/2 plus c. Okay, let's try cosine square root of x over square root of x. We're not going to pick cosine because the derivative of cosine is sine. So we don't want to pick cosine, but we'll pick what's inside the cosine, because as you see when we take the derivative, we have 1 over 2 square root of x dx, and this is our 1 over square root of x dx is what we want. That's right here. We don't want the 2, so we bring it over by multiplying both sides by 2. And so 2 du goes in for that, and we have cosine u to du, which we know is 2 sine u plus c, or 2 sine square root of x plus c. So don't be afraid to pick your u's, and if you pick them wrong, well, then you try something else. It's trial and error. U here is 3x plus 2 because it's inside the power. Du is 3. bring the 3 over because there's not a 3 outside in the problem. So dx gets replaced with 1/3 du, and this is u to the 10th. So we have 1/3 u to the 10th du is 1/3 u to the 11th over 11 plus c, or 1 over 33, 3x plus 2 to the 11th plus c. Okay.